Hi, it's MP the tutor again. And today we're going to look at something called completing the square, which is to do with quadratics. But the very first thing I'm going to do, which links to completing the square, is we're going to expand some brackets. So we might have something like x plus 4 in brackets squared. So if I'm going to expand that out, what do I get? Well, I'm going to do a little grid to the side. X and 4 times x and 4. And that gets you x squared, 4x, 4x, and 16. So that is x squared plus 8x plus 16. Or if I went something like, let's go x plus 6 squared. Do a little grid times x and 6. X and 6, you get x squared, 6x, 6x, and 36. So that gets you x squared plus 12x plus 36. Now, what you might notice with this is whatever the number is at the end, like here we've got like 4 at the very top, then if you double the 4, you get 8. And here, if you've got 6, you double the 6, you get 12. Yeah, so if I have one last one, let's go x minus 3 in brackets squared. Let's do a little grid. X minus 3, x minus 3. That gets you x squared, that's minus 3x, minus another 3x, and then that's positive 9. So that equals x squared minus 6x plus 9. So this is an example where we have x squared plus 10x plus 50 equals, in brackets, x plus something squared, or a, close bracket squared, plus b, where a and b are constants. So that means they don't change the numbers, just a value. So the way we go about this is, like last time, here we've got like the minus 6, so in brackets it's half that value. Now what we're going to do here is you have x plus 5 in brackets squared. So sometimes useful to write a little grid if you're still needing to practice this. X and 5, x and 5, because that gets your x squared, that gets 5x, 5x, and 25, so you have x squared plus 10x plus 25, and that's what that bit in the bracket is. But I don't want that 25. So I'm going to minus 25. And then that bit there is the x squared plus 10x. So the x squared plus 10x is that x plus 5 in bracket squared minus 25. Because what you end up having is your x squared plus 10x plus 25 minus 25. And then the 25s just cancel. But we still also have this plus 50. So what does that mean? Well, we then have x plus 5 in brackets squared minus 25 plus 50, so plus 25. So that is in our form we want. So we have x squared plus 10x plus 50 equals our x plus 5 in brackets squared plus 25. So we have x squared minus, let's go for 14x plus 10. What we first of all do is you have x minus 7 squared, because you half the 14. And do a little grid on the side because it helps. X minus 7, x minus 7. That's your x squared minus 7x minus another 7x. And then minus 7 times minus 7 is 49. So what we then have to do is you have to minus that 49, because then this bit here is this bit here. But we still have that plus 10. Then that's x minus 7 in brackets squared. Minus 49 plus 10 is minus 39. Boom. Okay, so now we have this one here, which is x squared plus 8x minus 13 equals 0, and it's been asked to solve by completing the square. So what we do here is you first of all have that x plus 4 in brackets squared. So do a little grid, x and 4, x and 4, that's your x squared, 4x, 4x, and 16. I don't want that 16 at the end, so I'm going to take away 16 and take away 13 still. So again, this bit here is this bit here, and that equals 0. We then have x plus 4 in brackets squared, minus 16 minus 13 is minus 29. That equals 0. We're going to put 29 on the other side by just adding it. So you have x plus 4 in brackets squared equals 29, and then we can get rid of the squared. So the opposite squaring is square rooting. So you have x plus 4 equals the square root of 29. And then the final step is to take away that 4. Before I do that, when you square root things, you often have a plus and a minus. So what we have is x equals plus and minus the square root of 29 minus 4. And that is solved. So solving by completing the square is you start off with the same sort of procedure, then you end up with putting it onto one side, square rooting it, and rearranging it, make it the subject. So here we have another one. Now, so far, all the values we've had have been even for the number of x's. Now we have 5. Now, it's not much different, but you end up with fractions, which can be a little bit annoying. But you get x minus 5 over 2 squared. So I often do as a fraction, because you have x and minus 5 over 2, x minus 5 over 2, that's your x squared, that's minus 5 over 2x, minus 5 over 2x, and then that is a positive 25 over 4. Because 5 times 5 is 25, and 2 times 2 is 4. So we then have to take away 25 over 4 plus 1 equals 0. What I then often do is turn the 1, or whatever value it is, into quarters. So we have x minus 5 over 2 squared minus 25 over 4 plus 4 over 4 equals 0. And that means we have x minus 5 over 2 squared minus 21 over 4 equals 0. We put 21 over 4 on the other side. So you have x minus 5 over 2 in brackets squared equals 21 over 4. Then we square root it. So then you have x minus 5 over 2 is plus and minus the square root of 21 over 4. And then that, 21 over 4 written like that, can actually be written as plus and minus square root of 21 over the square root of 4, which is 2. And then I'm going to add the 5 over 2 to the other side. So you have x. It's plus and minus root 21 over 2 plus 5 over 2, which you can then actually just make it a single square, single fraction, because they're all over 2. So plus and minus the square root of 21 plus 5 over 2. So it's very similar, you just end up with fractions which are a bit more horrible. Which is not too bad, I guess. It's just a bit annoying. Let me zoom out so you can get the whole thing. So let's have a little look at this next one. So here we have a 3x squared at the front. So we have 3x squared plus 4x plus 5 equals a brackets x plus b squared plus c. Now a, b, and c are just constants or just values. And what we do first of all is we first of all really are going to sort out this front bit here, this bit in red. because we have the 3x squared. And what we do is you put a 3, and you have brackets, and then we basically divide everything by 3. So we factorize out 3, and that's including with the x. So you have x plus 4 over 3, x squared plus 4 over 3, x. And you still have that plus 5, but I'll just check at the end. What we then need to do is completing the square with this bit inside that bracket. So I'm going to do a little multiplication grid. We have x and x to get our x squared. We need 4/3 x, and that comes by halving it, so 2/3 and 2/3. Because you've got x squared, 2/3 x, 2/3 x, and 2/3 plus 2/3 is our 4/3, and that then gets you 4 over 9. So you have 3 brackets, another bracket, x plus 2/3 squared, but then we end up having to take away that 4/9, and then we still have that plus 5. Now, what we tend to do now is to get that 4/9 outside the original bigger brackets. So we have still that 3 brackets x plus 2/3 squared, but I'm going to minus, you have 3 lots of like 4/9, or 3 times 4/9, and we still have that plus 5. So you can take out that 4/9 by multiplying by 3. So you end up with 3 still brackets x plus 2/3 squared. There's a couple of ways you can go about it. In terms of, you could do 3 times 4 is 12, and then you have 12 over 9. But that would also simplify to be 4/3. So that's minus 4/3 plus 5. Now what I can do with that 5 is I'm going to turn it into thirds, so I'm going to delete that. And that's then plus 15 over 3. We're almost there. So we have, I'm going to keep it in black now, we have 3 bracket x plus 2/3 squared minus 4/3 plus 15/3 is a plus 11 over 3. And that is our answer. So it doesn't have to be integers, and these ones don't tend to be if you've got annoying numbers like this. But that is our answer. So that is what equals 3x squared plus 4x plus 5. So here we have another question, which this has got 5x squared minus 6x minus 7 equals 0. Now, if this wasn't telling you to solve by completing the square, I would just use the quadratic formula because it's just easier and quicker. But I guess in the past, people didn't have calculators like 40, 50 years ago, and it was useful to be able to solve them without a calculator. But let's get started on this one. So we have this first bit here, which is a 5 brackets x squared minus 6 over 5x minus 7. So again, that minus 7 at the end, we just leave it for now. Then we need to do our completing the square. So we have our little multiplication grid. We have our x, and x makes you x squared. We need to half our 6 over 5, which gets you 3 over 5 and a 3 over 5. It's a minus, so they're both minuses. So that's minus 3 over 5x minus 3 over 5x. And minus 3 times minus 3 is 9 over 25. That's 5 times 5. So what we now have is you have 5 bracket and another bracket, x minus 3 over 5 squared minus 9 over 25. And then we then go minus 7 equals 0. The next step is to get that 9 out of 25 out of the bracket. Now, with this, when you've got a solving one, there's a 0. What I tend to do is I tend to keep the 25 fraction as a fraction of 25, because later on I know I've got to square root it. And if I can square root 25, then I can actually make it all as a single fraction at the end. So what we end up doing is you have your 5 brackets x minus 3 over 5 squared. And now I do 5 times 9 is 45 over 25. And then we still have that minus 7. Now, if I wanted to, which is probably a good idea, I wouldn't write minus 7. I would write that as 175 over 25. So that's 7 times 25 is 175. And that then equals 0. Then we have our 5 brackets x minus 3 over 5 squared minus, so you've got 45 and 175, which gives you 220 over 25 equals 0. Then we're just going to chuck the 220 over 25 on the other side. So you have 5 brackets x minus 3 over 5 squared minus equals, not really minus, equals 220 over 25. Then we don't really like that 5. So what we do is we divide both sides by 5. So then that gets you x minus 3 over 5 squared equals, now I can actually divide 220 by 5, and then that gets you a really wonderful 44 over 25. Then I'm going to get rid of the squared. So let's get rid of the squared, you square root it. So you have x minus 3 over 5 squared, well that was now square rooted, equals the square root of 44 over 25. There is a plus and minus, but I can also write that as the square root of 44 plus and minus over the square root of 25, which is 5. I then have x, and I'm going to get rid of that minus 3 over 5 by adding it. So you end up with plus and minus the square root of 44 over 5 plus 3 over 5, which I could write that as plus and minus the square root of 44 plus 3 over 5. Or, to save you the hassle of doing it that way, you could just use a quadratic formula. I have to say it is a little bit of a faff, but there's no calculator needed there, and it solves it. So it is a method to solve it, but as you can see, it is quite a long-winded method, especially if you've got a number at the beginning, but it's still part of the A-level, so it's useful, I guess, to learn. So why not have a go now? There's exercise 2C and 2D. There's quite a few questions in there, and have a go. Sometimes you might end up with a negative x squared, and you just have a negative 4, for example, outside the bracket. But have a go with exercise 2C and 2D, and hopefully you paused it, and you've now got the answers coming on the screen, and hopefully it's a bit more useful. I tend to use the quadratic formula for most of what I do, just because it's quicker and easier, and in all your exams you have a calculator, but they can ask to show it in a certain form. It's part of a 4-mark question or 5-mark question. 4 marks, I think it's 4 marks.